Welcome back. So this is the second video on an introduction to conditional probability based on NCEA level 3. In the first video we looked at what a conditional probability is and some examples of how to calculate it, and we looked at the notation for that. In this video we're going to look at developing a formula for conditional probability. The question that we're going to focus on in this video is really, well, questions 2 through to 4. We're not going to do all the questions, we're just going to do a sprinkling of them. So we're going to look at some where it's not a conditional probability, just to check that we can tell the difference. The first one that we're going to look at is, we're going to look at question 2C. What proportion took less than 30 days to sell, or sold between $300,000 and $600,000 inclusive? So what is this out of? Well, the answer is it's out of all of the houses, because it doesn't say any subgroup. It just says what proportion. So it's out of all of them. So when we look back at our table, the two events that we're interested in are selling for in less than 30 days or between $300,000 and $600,000. So in less than 30 days or between $300,000 and $600,000. And so what do? Pause the video and have a go. Well, what we do is we add up all of the numbers that are in either of those situations. So 39, 35, 8, 45 and 4. We have to add those up, and then it's going to be out of what? Well, it's going to be out of 181. So let's grab the calculator. So 131 out of 181. And we need to write that properly using notation. So 131 over 181. And the notation is, we use the symbol or the symbol union, which actually means or. So union, which means or. And the events are less than 30 days, which we're calling F, and or between $300,000 and $600,000, which we're calling D. So it's going to be the probability of F or D. So F union D. Or we could have written D union F and it would have meant the same thing. So question 2D, of those that sold for over 600,000, so it's only out of those that sold for over 600,000, that's our condition. What proportion were in the market for more than 90 days? So how many sold for over 600,000? The answer is 12. And on the market for more than 90 days was 0. So probability, given it sold for over 600,000, so that's E, what's the probability it was on the market for more than 90 days? Which is H, and the answer is 0 out of 12. That is zilch. Because if we pick a house at random from that particular group of sales, none of them fit that category, so the chance is 0. Doesn't mean it's not possible, but if we're only picking from those houses, we certainly can't get that because it didn't happen. Okay. What proportion sold for between $300,000 and $600,000 inclusive and took from 30 to 90 days? This is question E. What's this one out of? Well, the answer is it's out of all of them, because it just says what proportion. It doesn't say any subgroup, does it? So what proportion of all those houses sold for between $300,000 and $600,000 and also took from 30 to 90 days. So that's the middle column and the middle row, isn't it? The middle column, that's this one. The middle row. And the only part that's both, in both that column and that row, is the 45. That's what we call our intersection of the two events. The event sold for between 30 and 90 days and sold for between $300,000 and $600,000 intersect there. So 45 houses out of 181 were in both those categories. Now, the letters we're using, so 30 to 90 days, we're calling that G. So that's G unit. And $300,000 to $600,000, we're calling D. So that's D. So this is the intersection of the events D and G. So where D and G both happen. Well, those particular sales are a member of both events. Those 45. So it's 45 out of 181. And the way we write that notation, we use a symbol for AND. So remember, it's the probability of D and G. And the symbol we use for AND is this symbol here. It's kind of like an upside down U. So that symbol there means AND. It means they both happen. Sometimes called the intersection of the two events. So question G will do as well. What proportion of the houses that were on the market for more than 90 days sold for over 600,000? Okay, so what's it out? What's this question out of? Is it out of all of them? It says what proportion of the houses that were on the market for more than 90 days. So it's not, it's a conditional probability. The condition is we already know they were on the market for more than 90 days. That's the condition. So let's find out how many were in that category. So it's this one, and the answer is 19, so it's going to be out of 19. And the question is, the event is sold for over $600,000. So out of those houses, out of those 19 houses, how many sold for over 600,000? And the answer is 0. So 0 out of 19. So the probability, given the condition that the house was on the market for more than 90 days, which is event H, the probability that it sold for over 600,000, which is E, is 0, because it just didn't happen in this group of houses. So we're picking from that group of sales. It's not going to happen. Okay, so let's move on to question 3. Now, question 3 says comment on your answers for questions 2D and 2G. So 2D and 2G, what do you notice about them both? Well, they both had answers of 0. So let's write that down. Always start by stating the obvious when you get a question. So both had probabilities of 0. Why? Well, because in this group of houses, no houses sold for over 600,000 and were on the market for more than 90 days. That's why. So, in this group of houses, of sales, none that cost over $600,000 took longer than 90 days to sell. Now, there's a special name for that when the two events cannot both happen at the same time. So the event, we're picking a house at random from this bunch of 181 sales. And the events, a house sells for over 600,000 and sells for more than 90 days. They cannot both happen at the same time because no houses are in that category, are they? So what's the name for when two events cannot both occur at the same time? The answer is mutually exclusive. Mutually exclusive means that they mutually exclude each other from happening. If you tell me that you've picked a house from this group and it's sold for over $600,000, I can tell you that it definitely wasn't on the market for more than 90 days. Two events mutually exclude each other. Mutually exclusive. And the way we write that is we say that the probability of their intersection is 0. So what are we calling over 600,000? We're calling it event E. And more than 90 days, we're calling that event H. So we can say that the events E and H are mutually exclusive. So events E and H are mutually exclusive, which means the probability of E and H both happening is 0. A house cannot be in both categories at the same time. That was really question 3, wasn't it? I wrote it in the wrong place. Oh well. Okay, finally, the formula. This is the punchline we'll be moving towards. Formula for conditional probability. So question 4a, probability that a house sold for under 300,000 given that it sold in less than 30 days. So under 300,000, we're calling that C. Given that it sold in less than 30 days, what are we calling that? Less than 30 days is event F. So that's C given F. Okay, now the answer to that question is, let's have a look. What's the probability of C given F? Well, F, less than 30 days, that's going to be out of 82. And C is 39, so 39 out of 82. Alright, so 39 out of 82. One way when I do this question, remembering the C and the F, think of C as cheap. Under 300,000, the cheaper ones. Think of F as fast, because it sold fast. So the probability of a house selling cheaply, given that it sold fast. Okay, now what they're doing here is they're pointing out that the probability of, if we actually look back at the table again, moving towards a formula, this 39, if it was out of all of the 181 houses, that 39 would be the probability, 39 out of 181 would be the probability of a house selling for under 300,000, so C, and in less than 30 days. So C and F would be 39 out of all 181. Okay, so if we write that down, that would be C and F. So 39 out of 181, that would be the probability of C and F. Now, it's out of 82 though, isn't it? Because why is it out of 82? Well, it's given that it sold fast, given that it sold in less than 30 days. So that 82, what does that represent? Well, 82 out of 181, that would be the probability of a house selling in less than 30 days. So selling fast. So the probability of F would be 82 out of 181. So we get this kind of formula here, that the probability of C given F can be worked out as the probability of C and F divided by the probability of F. Why is that useful? Well, it's useful in a situation where we're given the probabilities as decimals instead of as counts. So here we're told them as counts, like 39, 35, and 8. And so if you wanted to know that conditional probability, you just count them. Well, it's 39 out of 82.